right, we're probably going to get started here. Hello, I see in the chat there. Hello, Andy from Perth, Ontario. I know a lot of people from across Canada, and I was telling our guests here that some people join us from Germany or India and kind of all over the world. So hello to everyone. Good morning, good lunchtime, good evening, depending on where you are. So I'm Natalie Irwin, Director of Stakeholder Engagement here at Efficiency Canada. I'm actually based in Ottawa, Ontario, Canada. I'm pleased to welcome today our two guest speakers from Windfall Ecology Centre, Brent Kopperson, Founder and Executive Director, and Mennie, Energy Resources Coordinator. They're going to be sharing how their data tools are used and analysis regarding residential energy retrofits in Southern Ontario. So very much looking forward to have them join us today. Just a reminder to everyone to please hold your questions for the end of the presentation, which will last about for 20 minutes. Our discussion period is also around 20 minutes, so we should be able to get to everyone's questions. Two ways to ask your questions. One is at the bottom of your Zoom screen. There's a Q&A box. You can type your question in there and I can narrate it for you. And the second way is that you can raise your hand and I will unmute you so you can ask your questions yourself. So without further ado, please join me in welcoming Brent and Kyle today. Thanks for joining us.
Thank you, Natalie, and thanks for providing us this opportunity. So as Natalie said, good afternoon. My name is Brent Kopperson, and I am the founder and executive director of Windfall Ecology Centre. I'm joined today by my colleague, Kyle Mennie, and Kyle is an energy resources coordinator and analyst with Windfall. And our topic is making data accessible for science-based policy. For those of you who are not familiar with our work, I'm going to provide some background on Windfall Centre and give some insights on how we use data visualizations, and machine learning in our operations. After that, Kyle will lead you through a demonstration of our public-facing data tools, which are available on our website. Specifically, one of the tools we created to analyze residential energy retrofits in Southern Ontario, that's what we're going to be doing a deep dive into today, but we actually produce tools for anywhere in the country. And before going on, I just want to make one clarification to clarify any misconceptions. Some of you may have seen a social media post advertising today's topic as the mass mobilization of residential retrofits in Canada. That post was made inadvertently, and we apologize if that is the topic that brought you here today. But I hope you won't be disappointed in what we are presenting. That said, Windfall is doing a webinar on mass mobilization in the new year, so hopefully you can, if you're interested in that topic, you can catch that. So Windfall Ecology Centre is a nonprofit social enterprise. We're dedicated to building sustainable communities. Windfall was created in 1998 and inspired by a vision of healthy communities where economic, social, and environmental needs achieve balance through social innovation, community partnership, and community action. The center's activities focus on powering communities to create lasting wealth in a carbon-constrained 21st century. We are known for innovation in the design and integration of public policy initiatives and the delivery of community-focused climate change mitigation and adaptation programs in collaboration with a host of partners, including community organizations, businesses, institutions, and we work with every level of government. We have 20 years experience in the residential energy efficiency sector, including delivering NRCan's EnerGuide for Houses program in the Greater Toronto area, designing and piloting Canada's first community-wide home retrofit program with the Chippewa of Georgina Island First Nation, and piloting a turnkey home retrofit program for low-income families in Ontario, which is now a ratepayer-funded province-wide program delivered by Windfall in partnership with Green Communities Canada across a broad swath of central and eastern Ontario. So let's talk about data tools. Over the years, we have become adept at the practical application of using large data sets. We use data to create interactive visualizations that bring trends, issues, and opportunities to life. And Kyle's going to be demonstrating one of those tools a little later. In particular, we can use data derived from thousands of on-site home audits to do much more than just visualizations. We use home audit data for benchmarking, to measure retrofit performance against emission reduction targets we set. We use it to identify neighborhoods with high emission reduction potential. In addition, large data sets enable us to explore optimized pathways to net zero emissions for very specific building archetypes. We also use home audit data to both build and validate machine learning models we create to qualify homes for retrofit programs or create more nuanced home archetype clusters for citywide energy modeling. As an example, we're currently working with a team developing the City of Toronto's net zero policy strategy for existing buildings. That team is led by the Integral Group with partners WSP, REAP Green Solutions, and Windfall Ecology Centre. And for this project, Windfall built a custom data tool that we use to validate outputs from a machine learning model created to enhance citywide modeling. I mentioned earlier that data visualization brings trends to life. For the last minute or so, Kyle has been sharing a static visualization of all EnerGuide audits performed in the City of Toronto between 2003 and 2019. Without diving any deeper, there are two big takeaways from what you are looking at. The first is that the number of retrofits completed in successive years varies markedly. Not surprisingly, the peaks and valleys align almost perfectly with the availability and level of incentives offered to homeowners. You may be surprised that the heydays of greenhouse gas reducing home retrofits in Ontario was during the Stephen Harper government years. During those years, there was $10,000 in incentives split between the federal and provincial governments. I think I'm safe in saying that the Harper government's primary motivation was not climate change mitigation for those programs, but they certainly understood the value of home retrofits as a rapid stimulator of local economic development and smart politics. They rebranded the previous government's retrofit initiative and doubled down as part of their economic action plan. Hopefully this is foreshadowing some good things to come in the residential energy sector across the country. But the second and more problematic takeaway from what you're looking at is that the average greenhouse gas emission reductions per retrofit have been declining over the years. At a time when we need to be ramping up the number of retrofits and crucially the depth of greenhouse gas emission reductions per retrofit, it's a bit alarming. In the mid-2000s, the average emission reductions per retrofit were almost 40%. By 2019, that had fallen to 23%, far below what is needed to get even close to a net zero objective. I'm going to leave you to ponder that. Think about the factors that underlie this disturbing but reversible trend, and perhaps time permitting, we'll come back and circle back and have a discussion about that later. With that, I'd like to turn you over to my colleague, Kyle Mennie, to take you through a deep dive into Windfall's EnerGuide data visualization tool. It's yours to explore. Kyle?
Yeah, thank you so much for the introduction, and thanks for everyone here for joining us. For the next section of this webinar, I will be walking you through our home retrofit data tools. We'll go through each of the visualizations that are hosted on the website today, as well as go through some hypotheticals of residential building questions. Before that, I do just want to provide a little bit of background information on the home retrofit data tools that we have on our website today. To start off, the evaluations actually do come from Natural Resources Canada through their EnerGuide home energy evaluations. If you haven't looked into these EnerGuide evaluations, I highly recommend doing so. We at Windfall provide these evaluations as well as many other organizations across Canada. A registered energy advisor for these would come to the home and do a comprehensive home evaluation. And from these, we get a lot of great data and the customers get a lot of great insights on their home energy efficiency, giving them information such as air leakage, insulation, energy use, and of course, greenhouse gas emissions. So with Natural Resources Canada being kind enough to provide this data to us, we wanted to create an easily accessible and engaging tools for data exploration. So we currently have 3 of these launched on our website today. These are for Durham, Toronto, and York regions. We designed these with simplicity in mind. It's just 5 visuals that is shown on the actual tool itself. But the idea is that these are highly integrated and allow for an in-depth data exploration and engagement, of course. So that about sums up the basics of the data tool. I guess next is just to jump into it by heading to our website here. So as you can see, this is our landing page for the Windfall Home Data Tools. If you're ever on the website, it's actually just accessed from the top tab over here. There's a little bit of a preamble just about the EnerGuide evaluations and some of the data that we've collected. I'll skip through that for now, and let's just go to the City of Toronto to take a look at the tool itself. So once this loads up, you'll see that the visualization itself is on the left-hand side. And on the right, we do have a selection tool to look at certain other areas like York Region and Durham, as well as some of the other projects that we've done in the past. Below that, you'll see some great links to the government website just to learn about EnerGuide home energy evaluations and registered energy advisors. And right below that, there's a little bit of information just about this dashboard. So I won't go through all of this with you, but it's a bit of an introduction, and it does also give some great information on the terminology that we use in our retrofit data tools. One important thing is what retrofits are themselves. These can be things like furnace replacements, adding insulation. Can also include things like fuel switching or heat pump integration. We have 2 different types of evaluations that are displayed here. There's ones that are done before a retrofit project and ones that are done afterwards. And another common thing that we'll focus on is greenhouse gas emissions, which is measured in tons of CO2 equivalent per house per year. There's also some great information on functionality here as well. But without further ado, let's just jump into some of the functionality that we have in the tool here today. Starting with our little filter icon in the top right-hand corner here. One interesting thing that you can do with this tool is you can filter the data to look at specific regions. Right now we're on Toronto, but once this loads up, you'll see that there's different options for Etobicoke, Toronto, York Region, etc. There we go. So by clicking on these, you can focus on specific areas to take a little bit more of a deeper dive into the exact locations. One really important tool that we have here today is actually our simplest tool. It doesn't have too much interactivity, but everything influences this number that you see on screen. So this is the % reductions of greenhouse gas emissions that you see from home energy retrofit projects. Brent spoke to this a little bit earlier, that this number has been declining. And you'll see as we play around with this, that this number will shift around to show where success is and where there's room for improvement. The second graph we see here today is the interactive graph for home energy evaluations per year. This one has 3 different things that we can focus on. So there's the pre-retrofit energy evaluations done before any work has been done to the house. The post-retrofit energy evaluations done after a retrofit has been done. These are labeled in thousands of evaluations itself. And then there's also the average emissions reduction percentage, which you'll notice also fluctuates quite significantly along through the years. One important thing to note is that the sidebar here denotes the percentage. So this is between 20% and 45%, not 0 to 100. One interesting thing that you can do with this visual is you can actually drill down to more specific dates. So this isn't just a static visual. Anything that you click on will actually filter the data by that amount. But we also have these really useful drill down features, which will be important through the remainder of the visuals. Using this, you can actually take a much deeper dive into the visualization itself. You'll see here we can click into the specific quarters. You can actually go farther than this. You can go to specific years and dates. This is 2017 Q4 December. You can actually go down to the specific day level if you're interested in taking that deep dive into the data. So that is our first visualization here. And the second one, moving along, is the pie chart that shows the types of housing that we see within Toronto specifically for this visual. So for here, you can actually look at the percentage of house types that are in Toronto. You'll see that on average, we have 70.8% that are single detached in all of Toronto, 26.7 row house. One interesting thing with this is you can actually click in to see the years of the actual house types itself. So if I click into single detached buildings here, you'll see it actually shows the distribution of years for that specific house type that we have. You'll see how in Toronto, the majority of the homes, or a large percentage, are 1950s and 1960s homes. And this is just something that you can do for both single detached, row house. We also have information on smaller things like apartments, duplexes, or triplexes. So that is the basic information for that one. Next, I will move over to our other graph here, which represents average greenhouse gas emissions, both for pre and post retrofit energy evaluations. So on the x-axis, you can see here it's actually by the decade of house construction. To note, this is different than the year built for the homes in the top here, as this is the energy evaluation date, and this is the date that the house was actually constructed. So a little bit of a difference there. And one interesting trend that you can clearly see is that older houses are less efficient. This is something that should come as no surprise to many of you. But as we notice, moving throughout the years, pre-1900s homes are the ones that could really use work with reducing greenhouse gas emissions, where when we get into the newer homes, there is less emissions there already. And it's also harder to actually reduce the percentage of greenhouse gas emissions by. So we might need to look into some more involved types of projects for getting to net zero and reducing emissions for those houses. Again, there's a drill down feature for this. One interesting thing that you can do is you can look into the specific years that were built for each of the housing types. So last is our emissions by district. This is actually a tree map that shows each district and is sized based on their average greenhouse gas emissions. So this is a nice graph that actually works somewhat similarly to the filter button. When you click on it, it'll go to Old Ontario or York and things like that. But the interesting thing about this is that you can actually drill down to the specific postal codes to get a more in-depth dive into the emissions in specific areas within these regions. So with this, you can really get a fine-tuned look at certain areas of interest. So that's a lot of information on the basics of these tools. For the next portion, I kind of want to bring this all together with a few questions in order to show how these interact together and how we can discover some answers to complex retrofit questions. So I have a couple listed here. We'll see how many we can get through. But to start off, one thing that's easy to notice is that Toronto is the area with the highest average greenhouse gas emissions, whereas Scarborough has the lowest. One interesting thing to look at would be what's the difference in housing types between these two areas. Maybe that'll go into explaining the difference in greenhouse gas emissions that we see here. So if you want to look at a specific area, you can use this filter button, selecting Old Toronto. Let's start off just for a look at their housing types. You'll notice this changed quite significantly. In the original pie chart that we had here, it was 70% single detached buildings and a small majority were row houses. You can see here that in Old Toronto, the majority of homes are actually row houses. So this is something that's interesting. And if you've been in Old Toronto, you'd recognize this with the old construction row houses as you go along the streets there. And similarly, if we look into this, you'll see that the age is reflected here as well. For the row houses, we have 1920s and prior homes have the vast majority of the housing stock for this area. You'll see the same thing for single detached buildings, where if we look into here, again, 1930s and prior is the large majority of the housing stock. And that's significant because the older houses do have more greenhouse gas emissions, as shown by our visualizations here. So let's compare that to Scarborough and see what we can find. If we look into here, it's actually it's dominated by single detached homes. And when we look into the year of house construction, it's newer construction relatively. 1980s to 1950s is the majority of the ages that we see here, and a similar story with the row houses. So hopefully that just gave a nice demonstration of how you can use this tool to really look at local issues and tell certain information about the house ages. Related to that, I did have another question just about Old Toronto. As you can see, it is the area with the highest greenhouse gas emissions per household as a district. But is it the highest remaining, or is the highest remaining postal code also in Old Toronto? One thing that if you're following along, you could tell that we could drill down, look at the specific years, compare. But there is an interesting way just to look at this and get a better look of all the postal codes as a whole. One useful thing for the tree map I find, especially if you're looking into postal codes, is you can expand this to the entire visual. Just have a better look at the screen here. But one great thing that you can do is you can actually expand to next level, and you'll get to see all of the postal codes within York region and the information of where they're related to. And through this, we can actually find our answer. Etobicoke is actually has a postal code with the highest emitting greenhouse gas emissions. You'll notice how Toronto has most of the others. But if you're looking for targeting a pilot program for reducing greenhouse gas emissions or marketing, Old Toronto is an obvious thing to start with, but there might be some areas in Etobicoke that could also be of interest. Moving along to one other question that I have. The emissions by decade built graph is one that you can see here. And that is one that has a pre-1900s homes section. And one question that I had is, how deep does this really go? This is a broad range of housing types and ages. I'm curious on how old the homes that we really have in this database are. This can be found by our drill down section, where we can drill down into these pre-1800s homes, and we can have an in-depth look at that. You can see that these start in 1899 and scroll all the way back to 1938 is the oldest house that we have on record. You can click into these and actually find some information on the actual emission reductions that we're seeing from these projects, 15% in this case. But this is a great way just to have a deep dive into the data and look at the specifics as well. One final thing before we finished off is just, let's say hypothetically, I want to promote energy evaluations in North York. To find the best time for marketing, what appears to be the busy months for home energy evaluations? So this is something that we can do as well with the visual here looking at our timeline. Hypothetically, if we're looking at North York, we can drill down, as I showed you, to look at the specific quarters and months, but this doesn't work for cross-year comparisons too well. One thing that I recommend if you're looking for cross-year is use the expand to next level function, which is something you can do by left clicking on the visual. By expanding to next level, you'll see here it shows the quarters. You can scroll along. And lastly, I think monthly is probably the best way to really look at the busy times that we have here. So this can look a little cluttered. The best thing that I recommend is if you're ever having trouble seeing something, you want to press on the expand so that you can take a better look at the data. But you'll see here there are some peaks. January, November, December, January does seem to be a time that has a pattern of higher energy evaluations with some divots coming in for the summer months. So if you want to look at targeting some marketing or you're just looking for a non-busy time for an energy guide evaluation, you would want to focus on November, December, January for the busy months and August or September for the lesser amounts there. I know that was a lot of information. Thank you for listening to my demonstration. We'll now turn this back to the actual presentation and get along some questions. Hopefully you have some questions for us. I know that there's a lot of information there. We'd be happy to answer them. So I guess I will turn this over to Natalie for some questions.
Perfect. Thanks so much, Kyle. And thanks, Brent. That was a great demonstration of your tool. Very useful. I know a lot of people were commenting in saying how awesome it is. So there's a few questions here already. So just a reminder to everyone, 2 ways to ask questions: the Q&A box at the bottom of the Zoom. Second way is to raise your hand and I can unmute you and you can ask your question yourself. The only rule that we have is the same one we have for presenters, which of course is no sales pitches, please. Stick to questions only. So our first question today is actually from Andy Cockburn. He also says great tool. Does the data collected include average reduction of energy demand post retrofit? He's curious about reducing emissions with conservation strategies and reduced dependencies on polluting energy generation.
Yeah, so for the data tool we have here, the greenhouse gas emissions is actually based on emission factors specifically from consumption data. So we do have measures for how much consumption you have of gas emissions, natural gas, basically any fuel type that's present in the home. And based on this, we actually do also have rates for the actual amount of costs that would be expected for the relative amounts of electricity, gas, etc. So we do have those consumption metrics available as well. Not specifically in this visual that you'll see, but it is something that we have the ability to work with. And is obviously a very useful metric for finding more about homes and saving on emissions.
So just to build on that, is this is a tool, the data available for the rest of Ontario or like outside of the province of Ontario, for example?
Yeah, so we actually have data currently for a broad swath of Southern Ontario. This reaches areas like Niagara, Ottawa, things like that. And we do have the ability to get more data. It does take a lot of work to format this data and put it into a usable format like you see here today. So that's why we have it launched in a somewhat limited version for just Toronto, York Region, and Durham. But it is something that we do look forward to expanding in different areas should the opportunity arise.
Perfect. So if anyone's interested, they should reach out to you guys. Perfect. Another question just to build on that is, have you evaluated high rises, like for example, condos or multi-unit residential buildings, or is it specific more so for residential?
It's specific to residential, from single detached to low rise MERBs, 3 stories and under.
Okay, perfect. Thank you. And then another question here. There's some people talking to each other in the Q&A, which is great. A question actually from our Director of Policy, Brendan Haley here. Are there retrofits not picked up by the EnerGuide data? For instance, Canada-wide, he knows Manitoba does not use the EnerGuide system. So in the regions you're looking at, so more Southern Ontario, what is your feeling about the amount of energy upgrades occurring outside the EnerGuide platform?
Yeah, that's a great question. And the answer to the question is the data is all from the EnerGuide for Houses program. It's a massive store of data. And it's, it just kind of underlines how important data collection is, and it's just another value of doing a real on-site energy audit is the data we collect. If we don't know where we've been, it's pretty hard to figure out where we're going, and it's also going to be pretty hard to measure performance as we move forward. So energy audits produce that. There is certainly stuff that is going on outside the EnerGuide for Houses program. You can see just by the visualizations that the uptake of that program certainly is stimulated by incentives, and there is a lot of retrofitting that goes on outside of incentive programs. But it's really hard to evaluate just the extent to which that is happening. Certainly, we think the majority of it is happening within the EnerGuide system where it's being used.
Perfect, thank you. I actually have a question here from Lynn Robichaud. I'm just going to tweak it a little bit. She's actually interested in like how this tool or your work was funded. I think she's asking because if she were to go outside of Southern Ontario and wanted to do this work, who should she approach? Should she approach municipalities or the province or federal government or funders or?
Well, we produce these visualizations because we think they're really important to the sector moving forward, to understand what's going on out there in the residential energy sector. These initial visualizations that we're presenting, we produce these with our own funding, and they are, yours to discover and freely available. We have also done. We also do this kind of work on a fee-for-service basis.
Perfect, thank you for that. It's important piece always.
Yeah.
Another question actually from Brendan is the baseline used to calculate the GHG reductions by building age from the audits themselves with blower door tests? Or is it using scores like Enercan comprehensive energy database, or is it a combination of the two?
Yeah, so the greenhouse gas emissions and the energy consumption is actually calculated by the HOT 2000 system, which is from Natural Resources Canada. So it is modeled results based on factors in the home. This goes a lot deeper though than just square footage or age of home and things like that. They do look at insulation, the blower door tests and things like that that you mentioned, but they also have local factors that they put into that, such as solar heat gain, temperature related patterns. So it is a really complex modeling software that's used for these greenhouse gas emissions. But it's based on a combination of factors from modeling from Natural Resources Canada.
Perfect, thank you. Just a question here from Matthew Decosta. Please forgive my lack of geography knowledge of Southern Ontario, but he's asking, is Lamberton County included in your data? Or is it coming soon? And you might not know the answer to. We might have to go to Google Maps.
Yeah, I might have to go to Google Maps. I have a suspect that we do have it for the Lamberton region. And to be clear, it is something that if we don't have the data currently in our formatted database, that doesn't mean that it's something that we would never be able to provide, even if it didn't exist for our specific region. It is something that we could request. That being said, the area specifically is postal codes that start with M, L, N, and K. So if your postal code starts with one of those, then you're in luck. We have your data.
Perfect. He just answered he's west of London, so could be the case. But thank you for the clarification on the postal code. That's definitely helpful. Narrows it down a lot. I have another question here from David Katz. Is does it have the measures that were implemented as they are measured or after they're in? Does that question make sense?
So we have two different files that are split in the visualization. The initial energy evaluations are the ones that are the house modeling before any retrofit work has been done on the home. So that is what is specified in that category. And for the second category, we have post-retrofit energy evaluations. So there's two typical types of EnerGuide evaluations that you'll have in a home. The first one is a detailed initial inspection, which will take a lot of time going through the house, modeling it. And the second one will be a final evaluation where they will come back, see the retrofit work that you've done, redo things like the blower door test, and then give you a report letting you know how successful your retrofits were, what you could see for the improvements in energy consumption or greenhouse gas emissions. So we have those split into two categories in our visualization. So we have both, if that answers the question.
Perfect, thank you. Another question here is from Susan. She asked two questions. I'll ask her first one. It's kind of a yes or no question, so fast one. Is there a possibility to add data from past microfit program and current electricity generation programs?
The answer to that question is yes, definitely, and we're actually starting to overlay this data with all kinds of new information, even psychographic information.
Awesome. She also says, excellent tool to visualize data. So she's, a lot of people are saying the same thing. So I think people are really excited. And just a reminder to everyone, we are actually recording this session. So it's going to be available on our website under the Discovery Sessions archives, where you can find all past Discovery sessions, which is a great tool for just reviewing something that you've seen before, or sharing it with your colleagues as well. And so her second question to that is, has this tool been shared with Enbridge so that they can optimize their rebate programs to encourage upgrades that have larger GHG emissions reductions?
Well, certainly we work very closely with Enbridge. We deliver several programs in Ontario on behalf of Enbridge. So certainly we are communicating with Enbridge. But I think we're coming, to a time here where it's very clear from the data we're looking at and the targets that we're setting for ourselves in terms of, getting to net zero by 2050, which is, a science-based target, that we really need to change the way we are incenting programs, the kind of things we are incenting. We need to consider other factors that we haven't considered in the past when we're doing home retrofits. One of them is embedded carbon, which in fact is going to play a very important role moving forward in determining the materials that we use and what materials we incent to be used, and also the kind of measures that we are going to be making available. Clearly, from the modeling work that we've done and seen others do, there is no retrofit pathway to net zero emissions that doesn't include fuel switching. And fuel switching over the next 30 years as we move to 2050 is the name of the game.
So just a comment on that from Enbridge themselves. I was hoping someone from Enbridge, I'm sure they will be on the call. So they did say that they do look at this data very closely and to support their home energy rebate program. So Enbridge just has energy efficiency programs as well. So they do look at this data, which is not a surprise, which is great, but also great to be confirmed as well. So thank you for jumping in there, Jenna from Enbridge. I'm gonna go and to Brent for his answer as well. I'm just gonna jump to actually Christy Dreyer has a very interesting question here regarding the actual audits. She said if these are from actual audits, she would expect them to be concentrated in wealthy neighborhoods. Is this something that you guys have found?
That's an interesting question. We haven't actually overlaid income data with this data set, so I imagine there likely would be some alignment there.
Yeah, I would say if anyone's on the call from the provincial or federal or even municipal governments, if there's funding to provide free audits or subsidized audits, that's always welcome as well, and it allows equal playing field for everyone to participate in a home energy assessment. So I'll just
I should add though that there are some pretty significant retrofit programs available free of charge to qualifying low-income families. Enbridge delivers those programs. They've been around for quite some time, and we wouldn't be capturing that work in this data set that we have, and perhaps one day along with Enbridge we might be able to provide that.
Yeah, that would be interesting. I also know that if anyone wants to contact Enbridge directly on this, I'm happy to make the connection as well. That goes for the people that are presenters today or anyone on the call. Just let me know as well. Just a few more questions because we do have a few minutes left. One of them is from Kevin here. He says that my understanding is that there's been a lot of engineering / modeling work in the past decade to address the deficiencies of EGH assessments done in semi-detached homes. Have those improvements been incorporated and applied retroactively to past audits of semi-detached homes, which are predominantly older?
No.
Okay.
Yeah, so just to jump in for that, we have been, for greenhouse gas emissions specifically, that was a factor that actually wasn't integrated into past EnerGuide evaluations. They provided consumption data, but not that specifically. We have used the most recent greenhouse gas emission factors for providing that into our data set. So in that sense, it has been retroactively based. But none of the evaluations have been remodeled through the newest rating system.
Perfect. Thank you. Thanks for that little add-on there, Kyle. So just looking at the time here, is there any last minute words of wisdom or anything Brent and Kyle want to add just before we head off?
From my perspective, I just think that we often hear people talking about the expense of energy audits, and it is expensive to do energy audits, and we can't always do an energy audit on every single home, but there is great value in doing an energy audit, and that value falls both to the homeowner and as an educational opportunity to learn a lot about their home and making sure that you do the right things when you do eventually retrofit your home. And we shouldn't underestimate the value in the data that we're collecting through the performance of those audits, because without this data, it would be very difficult, much harder to plot our path forward to 2050.
Yes, thank you. Anything you want to add to that, Kyle?
Yeah, I definitely second that. Actually, a part of my other role here is working with homeowners and helping to coordinate these energy evaluations. And I have had a lot of success stories for people who have done really involved projects like exterior reclads or just some improvements to their house with insulation or draft proofing or windows. So it's something that I'm always happy to talk about and help people with, and I couldn't be a larger advocate for it as well.
Okay, perfect. So you're probably like me, you say you work in energy efficiency and all of a sudden you get all these questions about how someone should, what someone should do to upgrade their own home. Yeah, inevitably, it's always the question. So thank you again to our presenters from Windfall, Kyle and Brent. Please join me next Friday for another discovery session. I'm actually going to be joined by Jesse Rowe, who's the former VP of Corporate Performance of Energy Efficiency Alberta, as well as Bernd Donkers, Energy Futures Lab Fellow, who will be presenting on demand-side solutions to avoid distribution upgrades from electric vehicles. So more specifically, they're going to be sharing results from an EV project done by Energy Efficiency Alberta with fantastic results that we wanted to share, that even though Energy Efficiency Alberta is no longer in existence, we wanted to get this information out there to the sector. So they've agreed to come and present at next week's discovery session. And these results that they have actually indicated that energy efficiency and demand response actually cost less than smart charging. So of course there's a disclaimer that all three technologies are required to sufficiently reduce impacts on certain levels of EV uptakes, but I know I for one am interested on how the results of their studies that they've completed. So I hope everyone enjoyed today's presentation as much as I did. And a reminder, the recording will be on our website more than likely next week. And I hope everyone has a safe and happy and socially distanced Halloween this weekend. May you get enough, share the chocolate around so that you don't have to eat it all yourself. All right, thanks everyone and have a great weekend. Bye.
Thank you, Natalie.
Happy Halloween. Take care.
Yeah, you too.